Hi students, today we're going to look at prime versus composite numbers. Now prime numbers are numbers that their only factors are 1 and themselves. And it's important that you know those. Composites have more than 2 factors. That's the easiest way to define that. But let's look at how you figure out the primes. This looks labor intensive and it starts out that way, but it actually gets easier as you get into the bigger numbers. Let me show you. We're going to circle 2. Please notice that 1 is not here because 1 is neither prime nor composite. So it's a loneliest number. So start at 2, and now you're going to cross out every single multiple of 2, which is going to be pretty easy because I just have to do all the even columns the way that they've done this. So it's kind of a mess, isn't it? I think I'm going to X them out so it looks better. Okay, so I X'd those out. Now, the next step says to circle the 3. And now cross out every single multiple of 3. If you don't know them, you can go, okay, 1, 2, 1, 2, 3. There's 1, 1, 2, 3. I'm going to pause this and get them all. Okay, again, if you couldn't skip count by 3s, then just counting off 1, 2, 3, hitting every third one, that's kind of easy. So far 2 and 3 are prime. Now we're going to circle 5 because it's prime. Its only factors are 1 and itself. And I'm going to hit all the 5s. I've already gotten the 10s. You know, 5s, it's 5, 10, 15. I've got all the 10s when I hit the even ones. So all I have to do is cross out this row. Easy enough. Notice I didn't pause it this time because need a little bit more direction now. Now for 7, I'm going to circle it. But here's the deal. I don't have to keep on counting off 7s until I get to 7 times 6. And the reason why is because I've got all, if there's a 7 times 2, I've already hit it when I hit the 2. If there's a 7 times 3, I hit it when I hit the 3s. 7 times 5. So I'm going to start with 7 times 6, which is of course 42. And 7 times 7 is 49. 7 times 8 is 56. Already got it. 7 times, what was that, 8, 9 is 63. Already got it. 7 times 10, 7 times 11, 7 times 12 is 84. It's already gone. 7 times 13 is 91. I'm going to check that real quick. And then 1, 2, 3, 4, 5, 6, 7. That's at 98. So I'm going to check. I think it's 13 times 7 is in fact 91. So I've got all the 7s. It gets a little bit easier from here. Now the next prime is 11. Well, I'm going to get all the 11s, and those are easy, as you know. It's everything on this diagonal. And they're already checked off, right? Next prime, 13. Now, since everything has been crossed off, we know that 13 times 2, 13 times 3 has already been hit. 13 times 4 is, of course, hit when you hit the 2s. The 5 has been hit. The 6, the 7. As I said before, 13 times 7 was 91. And then, of course, there's only 9 more numbers after that. So that's it, right? So let's look at our primes because that's what we have left. And if you're like, wait, what about these? Well, let's say I've already done 17 times 2 times 3 times 5. 17 times 5 is 85. And then you don't have 17 left, do you? And of course, the next one's 19. You've already got 19, all these multiples here. So, and 19, let me do it real quick. 19 times 7 is 133. So you're off the charts, in other words, at this point. So I'm going to highlight in yellow. Well, I already started in red, so I guess I'll do it in red. Here are my primes. In this column, the ones that end in 1, and then this column seems to be more 3s and 7s to me, things that end in 3 and 7 than any other number. I've never really counted them up. I probably should. And then there's nothing that ends in 8, but there are some that end in 9. and that's it. So notice that all your primes end in a 1, 3, 7, 9. Now, not all of them that end in that, but that kind of helps you if you're working on something and you get a, well, that's kind of easy. What would be a hard number? I don't know, 74 or 51, knowing whether or not that's prime. You kind of know which ones that end in a 1 are prime. I find it really advantageous to have people memorize all the primes less than 20. I have had kids memorize all the primes less than 100, but I don't know that they've really remembered it the next year, so I don't do that a lot. But anyway, there you go with that. Hold on, I'm going to show you some problems to go with this. On your worksheet, I have some problems for you to work with that sieve of Erastothenes. It's just to kind of get you working with some of those prime numbers so that maybe it'll jar your memory. But there's some good problems here that I really want you to do. And now we're going to get into prime factorization. We've done that before, but I'm going to make a new video on that. You take care.